Hello, for the second part of our video on forces part 2, we're going to be looking at finding the resultant vector when we have two vectors that are not in the line. So now we're looking at two-dimensional. So the first thing I need to do is I need to measure the length. So I'm going to use this right here. This is one type of compass. I will show you both. And I will dial in the length of this vector. I'm going to set it now over here. And I am going to draw an arc on this side here. Now I need to go and take the length of this vector. So I'm going to place this right here, pull this down so it is the setting. Right here is our length. And I'm going to place it on this point here. I'm going to hold this down, place my pen in it. Alright, so the point where they cross is going to show you where your resultant's vector direction is. So I'm going to lay my ruler, which is very convenient on this compass because it is built in, right here, and I will draw a line from this point to the point where the arcs cross. So this shows you the direction of your resultant vector. So in this case, we're going to have northeast as our direction, so I'm going to go ahead and put northeast here. But now I need to figure out how the size or the magnitude of this force is. So to do this, I'm going to measure the length. So I've got 1 centimeter to about 3.7 centimeters. So I've got 3.7 centimeters. My conversion is 1 centimeter equals 1 Newton. So I've got 1 Newton per 1 centimeter, which gives me 3.7 newtons as my force. So let's look at this next one. I'm going to put my, actually let's use the other compass for this one. This is probably a compass more of you are familiar with. So I'm going to measure, using my compass, the length of the vector. I'm going to place this right here and then make my arc. Now I need to take and use the compass to measure the length of this vector. Place it right here and do my arc. So this point here is going to be my resultant vector. So I will take my 2 points, the point where they intersect, the vectors intersect, and then where the arcs intersect, and connect them. This gives me a length of 2.5 centimeters. And I have 1 centimeter equals 5 newtons. So 5 newtons for 1 centimeter. 2.5 times 5 gives us 12.5 is our force. So 12.5 newtons. And our direction is going once again northeast. So this is called the parallelogram method because if you actually connected this dot to the ends of our vectors, you would make a parallelogram. You will use the same method to make parallelograms, possibly in geometry class. So I'm going to go ahead and do the next one. I do prefer this one because my ruler is built in, so this is what I'm going to primarily use. So I will place this at this point, use it to dial in my measurements. Okay. So then I'm going to come over here, place it at the end of this vector, and make my arc. Okay. I'm going to come over to this vector. Alright, I'm going to dial in my measurement, take it to this point here, and make my next arc. So I have my point. So now I need to measure it. I'm going to take from here to here, which is 5 centimeters. So I've got 5 centimeters. Now in this case, each centimeter equals 100 newtons. So 5 times 100 gives us a net force of 500 newtons. And our change in motion is again northeast. So now we have 3 vectors, so this is going to be a little bit different, but we're going to start the same way. So I'm just going to work with these 2 vectors right here. I'm going to go ahead and number them 1, 2, and 3. And then we're going to break this into 2 parts. Okay, so I'm going to start with this vector here. I'm going to use my compass to dial in my measurement. Then I'm going to place the compass at this point. Oops, moved it. Place my pen inside and make my arc. I'm going to use this one to find here. All right. So now I need to go to this point and make my arc. We have our resultant vector. Okay. So now I have my resultant vector. I am going to use this as my new vector to combine with vector 3. So I'm going to find the length of it. Okay. And then I'm going to place this at the point of 3. I'm not actually measuring at this point because I have to account for this third vector. On these pages, it might help you if you use different color pens, just to kind of help you keep track of where you're going. Okay, so I'm going to measure this vector. Okay. And I'm going to place it at the end of this one here. The big old spot we made earlier. I'm going to draw my arc. So, alright, so my resultant vector of these is going to be, so it will be right here on this one here. So I'm going to take this and I'm going to measure the length. Alright, so I'm going to take it. I'm still using that same center point, but now here's my vector. And in this case, we are right at 4 centimeters. So 4 centimeters is our resultant vector times 40 newtons per 1 centimeter. So 4 times 40 gives us 160 newtons. And we are almost directly at this point. See, we are still going northeast. Alright, so let's do one more 3 vector together. So I'm going to number my vectors again in the order I'm going to use them, just to kind of help me keep my mind straight. And in this case, I'm actually going to choose both a pencil and a pen just to make it a little more clear for you. So I'm going to start by measuring number 1. Okay. I'm going to place that on the end of vector number 2 and draw my arc. Then I'm going to measure the length of number 2. Gives me there. So then I will take it to the end of number 1, place my finger on it, and make my arc. So let's go ahead and draw our line. So here is our new vector that we're going to use. So we're looking at this vector, draw resultant between 1 and 2, and number 3. So I will start by measuring the length of this one. Come to the end of 3. And I'm going to draw this arc in pencil just to kind of keep me straight. Okay. And then I will go and measure the length of number 3. And take it to the end of my first resultant vector. And we can see where it crosses. This is a lot more clear when I'm using 2 different ones. So I'm going to draw this one here. So as you can see, the resultant vector in this one is almost the exact same direction as number 2. So this is going to be, we're still slightly northeast. Now they can be in any direction. It just so happens on this worksheet they're mostly northeast, just because of layout issues. And this one is about 5 centimeters. So 5 centimeters times 25 newtons per 1 centimeter. So 5 times 25 gives me 125 newtons northeast. Okay. So down here we just have some practice on kind of overall understanding pushing versus pulling force and balanced versus unbalanced force. So as you can see, your paper ends up very